Okay, for linear equations review, we're going to start with writing the equation for the line that passes through points -3.5 and then +3.5. So keep in mind, a line means y equals mx plus b. That b could be 0. And remember that you need to find your slope. So it looks like we have a choice of a slope of -6 or a choice of -1/6. So let's see which one it is. So slope is your change in y over your change in x. Remember, this is x, this is y, x and y. So y goes from 0.5 to -0.5. So that's a change of a 1. So -1 from positive to negative. And then the x goes from -3 to +3. So that's a change of 6. So I can tell right now that my slope is -1/6. So I can cross those two off. Now the next question is a little bit trickier. It's, do we have a y-intercept of 1 or do we have a y-intercept of 0? So when we're doing that, you could write your table. So you've got your x and y. We've been looking at tables this year. So if we have a -3, -2, -1, 0, 1, 2, and 3, we're trying to find out what our y value is when our x is 0. So let's go ahead and pop in what we know, -3 and 0.5, and +3 and -0.5. And you know that you're going by a change of 1/6. So that's going to be a pretty slow road to do this. So let's check and see. Let's use our base equation instead. So let's take our y equals mx plus b. And we know our slope is -1/6, so let's do our -1/6 x plus b. And let's just pick a point to plug in. So I would pick my +3 and -1/2. So we'd say, okay, y is -1/2 or -0.5. And our x is +3, so -1/6 times +3 over 1 plus b. Then we're looking at just multiplying across. So -1 times 3 is -3. 6 times 1 is 6. So you've got -0.5 equals -0.5 plus b. There's an x there. So when you add -0.5, you're going to want to move it to the other side. So you're going to add 0.5 to both sides. You'll be able to see, oh, this is going to cancel out to 0. So that means my b is 0. So my answer would be choice A. So our next one, function j, is shown on the coordinate grid below. If the y-intercept of r is 3/2 greater than the y-intercept of j, which equation could represent? So we've actually seen this question before. Let's take a look. So the y-intercept is 3/2 greater. Okay, well, let's find the y-intercept of this one. The y-intercept of this one is -1. So if it's 3/2 greater than that, so -1 plus your 3/2, it's really -1 plus 1 1/2. So that's really 0.5. So look at which equation has a y-intercept of 0.5, and that would be choice C. So that is your answer. So you're just identifying that y-intercept and then finding the new one. Let's look at the next one. The temperature in degrees Fahrenheit and temperature in degrees Celsius. What is the meaning of the y-intercept? So I want to locate the y-intercept first. So here it is. And it says degrees Fahrenheit. That's my y-intercept. Keep in mind, y-intercept, your x value is 0. So we're saying that for 0 degrees Celsius, you have 32 degrees Fahrenheit. So I'm just going to note that 0 degrees Celsius is equal to 32 degrees Fahrenheit based on that picture. So what is the y-intercept? Now I can look at my choices. So it's not going to represent a change because it's a starting point, so I can rule out A and B. And it says for C, the temperature in degrees Fahrenheit when the temperature is 0 degrees Celsius. So that matches what I said. Let's just check D. The temperature in degrees Celsius when the temperature is 0 degrees Fahrenheit. No, because it's not 0 degrees Fahrenheit. It's 32 degrees Fahrenheit. So it's choice C. Our last one is kind of tricky. It's asking us to look for slopes. So we have three students represented on this graph. We have time in seconds, and we have distance in yards. and it says the relationship between the distance that they run and the time for Kofi, so I'm just going to do that, is represented by this equation. So that means Kofi has a slope of 15.55. So what does that mean in this situation? That we know our slope is change in y over change in x. So she's going 15.55 yards for every 1 second. Okay, so Elsie is faster or slower than her, you want to check. And I'm going to say her slope is not quite as steep, so she is a little bit slower than her. So if we're looking at slower, we'd be looking at a smaller number. And we want to check Bella. Bella is a little bit faster than Kofi. So I'll pick a different number here, or a different color. Bella is a little bit faster. So if Kofi is 15.55, Bella has to be bigger than 15.55, and Elsie has to be smaller than 15.55. So I'm looking for a Bella that's bigger than 15.55 and Elsie that's smaller than 15.55. So I see that in choice D. Bella is 15.85, so that would be matching that it's larger. I should put that over here, and that Elsie is 15.15. I don't see that in any other scenario. And that wraps up linear equations 1.